We're in Rosen, Discrete Mathematics and its Applications, section 10.2 on graph terminology and special types. In this video, we will focus mainly on the basic terminology of graphs, and other readings and videos will address the other areas of this section. We'll start with some definitions. We say that two vertices U and V are adjacent or neighbors in G if there's an edge between them. We say that an edge is incident with its vertices and that the edge connects the two vertices. And if we take all the neighbors of a given vertex, we will call that N of V. We say that that is the neighborhood of that vertex. And we can consider a subset of vertices A, and we can say that the neighborhood of A is the union of all the neighbors of V in A. So we have the concept of a neighborhood of a subset of vertices, as well as the concept of a neighborhood of a vertex. And now we have another definition. The degree of a vertex, we're talking about undirected graphs here, is the number of edges incident with it or incident upon it. And a loop, since it has two edges, will contribute 2 to the degree of that vertex. And we designate the degree of a vertex by the expression dEg of V. All right, so here's an example. What are the degrees and neighborhoods of these vertices? Well, the degree of A is 2, and the degree of D is 1, and the degree of G will be 0. And what's the neighborhood of A going to be then? Well, the neighborhood of A will be B and F. The neighborhood of D is C. The neighborhood of G, well, that'll be the empty set. So we see that the neighborhood of G is the empty set, A is B and F, and D is C. All right, what about this multi-graph on the right? Again, it's an undirected graph, so our definitions apply. We see that the degree of A is 4. The degree of B is 6 because it has 4 edges that connect B to other vertices, but it also has an edge connecting it to itself, which contributes 2. E also has degree 6, C has degree 1. And the neighborhood of A is B, D, and E. Even though it has degree 4, it only has 3 neighbors. The neighborhood of B contains B because it is connected to itself with that loop. And again, E only has 3 vertices in its neighborhood, even though it has degree 6 because of all the multiple edges. All right, here's our first theorem. In this section, it's the Handshaking Theorem. It says if you have m edges, then 2 times m is equal to the sum of the degrees over all the vertices. And the proof is that since every edge contributes twice to the degree count, the sum of those will equal twice the number of edges. What that means is the sum of all the degrees will be an even number. And here here's an example. If we have a graph that has 10 vertices of degree 6, that means the sum of all the degrees will be 60, and then divide that by 2 to get the number of edges to be 30. What if I have 5 vertices each of degree 3? That means the sum of all of my degrees is 15, but I can't create such a graph because 15 is an odd number, and there's no number of edges that will give me that sum of degrees. That gives rise to our next theorem, that in an undirected graph we have an even number of vertices with odd degree. And the way we'll prove that is we'll partition our vertices into those of even degree in V1 and those of odd degree into V2. And then if I have m edges, 2m is equal to the sum of the degrees of the vertices. That equals the sum of the degrees of the vertices in set V1, sum of the degree of the vertices in set V2. Well, 2m is an even number. The sum of the vertices of even degree must be even. And then that means the sum of the vertices of odd degree must be even. In order for that to be the case, there must be an even number of such vertices. And that is your introduction to graph terminology.